the weighted mean. A value called the weighted mean is often used when some data values are more important than others. For instance, many professors determine a student's course grade from students' tests and final examination. So consider the situation in which a professor counts the final examination scores as two tests. To find the weighted mean of the student's scores, the professor first assigns a weight to each score. In this case, the professor could assign each of the test scores a weight of 1 and the final exam scores a weight of 2. Thus, a student with test scores 65, 70, and 75 and a final examination score of 90 has a weighted mean of 65 times 1 plus 70 times its weight 1 plus 75 the score times its weight 1 plus 90 the final score times its weight 2 over the total number of weight 5, which is 390 over 5 or 78. Note that the numerators of the weighted mean above is the sum of the products of each test scores and its corresponding weight, and the number 5 in the denominator is the sum of all weights 1, 1, 1, 2, which is equal to 5, and the procedure to find the weighted mean can be generalized as follows. The weighted mean of an n numbers x1, x2, x3 up to xn with respective assignments of weights such as w1, w2, w3 up to wn is equal to the summation of x times w over the summation of w, where the summation of x times w is the sum of the products formed by multiplying each number by its assigned weight, and the summation of w is the sum of all weights. Now, let us consider this table. Many colleges uses 4-point grading system, where A is equivalent to 4, B is equivalent to 3, C is equivalent to 2, D is equivalent to 1, and F is equivalent to 0. The table shows Dillon's fall semester course grades. Let us use this table to find the weighted mean for Dillon's GPA. The solution: the B in English is worth 3 points with a weight of 4. The A in History is worth 4 points with a weight of 3. The D is worth 1 point with a weight of 3. And the C in Algebra is worth 2 points with a weight of 4. The sum of all the weights is 4, 3, 4, and 3, or which is equal to 14. Thus, the weighted mean is equal to 3, Dillon's grade in English, times 4, its course unit credits, plus 4, the grade of Dillon in English, or in history rather, times its corresponding weight 3, plus 1, the grade of Dillon in chemistry, times its corresponding weight 3, plus 2, which is Dillon's grade in algebra, times its corresponding weight 4 over the total weight 14, which is equal to 35 over 14, which is 2.5. Thus, Dillon's GPA is 2.5. Consider this. Data that have not been organized or manipulated in any manner are called raw data. A large collection of raw data may not provide much readily observable information. A frequency distribution, which is a table that lists observed events and the frequency of occurrence of each observed event, is often used to organize raw data. For instance, consider the following table, which lists the number of laptop computers owned by the families in each of the 40 homes in a subdivision. This frequency distribution table was constructed using the data from the previous one. The first column of the frequency distribution consists of the numbers 0, 1, 2, 3, 4, 5, 6, and 7, and the corresponding frequency of occurrence f of each of the numbers in the first column is listed on the second column. Now, when we are looking for the weighted mean of the frequency distribution table, we can use the same function, the summation of x times w over the summation of w, but in this case, instead of using w1, w2, w3 corresponding from the weight, we will use f1, f2, f3, f4, so on and so forth, which corresponds to the frequency of occurrence. Henceforth, the solution for the aforementioned problem, what is the mean of the frequency distribution table? We get 0 times 5 plus 1 times 12 plus 2 times 14 plus 3 times 3 plus 4 times 2 plus 5 times 3 plus 6 times 0 plus 7 times 1 over 40, which is equal to 79 over 40 or 1.975, which means that the number of laptop computers per household for the homes in the subdivision is 1.975.